In this example, we'll perform A/B testing in Phoenix by utilizing projects. Oftentimes, you'll want to customize various aspects of traces that are logged into Phoenix. A project can be considered a collection of traces and a container for traces related to a single application or service. You can also have multiple projects with multiple traces in each. Some use cases of projects can be separating testing and production, even looking at two different applications. Our use case today is a RAG chatbot, in which questions are asked against a pre-built index of Arize's documentation. While the same questions are asked in each project, what differs is the model. For this example of A/B testing, we utilize GPT-3.5 and GPT-4. We want to compare the performance of both models with respect to the hallucination rate and QA correctness rate. Inside of Phoenix, you'll notice that we have both projects and the traces are loaded in both. So I will open both and we can perform a side-by-side comparison. So to get the hallucination rate, we end up using what are known as evals, which is an LLM as a judge, where the output of our LLM is calculated by a separate LLM. They also provide a label and explanation for the label. The hallucination rate and QA correctness rate utilize Phoenix's pre-tested evals, which can be found in our documentation. To start with the hallucination rate, this determines if an answer to a question contained false information based on the reference text. What we'll do is filter each group of traces for hallucinations. Now, what we notice is that the hallucinations do not happen on the same traces. For example, inside of GPT 3.5, the question was asked if Arize supports training data, with an output of Arize not supporting training data. When we look at the eval, we see the label is hallucinated with a score of 1. We also have the explanation for the answer. What we notice is that the reference text does mention Arize as a platform for monitoring, but it does not explicitly state Arize not supporting training data. Because of this, the answer isn't supported by the reference text and is a hallucination. If we compare GPT-4, the question being asked was how to use the SDK to upload a ranking model. The answer was provided, but again, it was a hallucination. What we notice is that it doesn't provide instructions or details on how to use an SDK to upload a ranking model. By extension, would mean it is a hallucination. Additionally, we can look at the Q&A correctness rate. In this example, you have to determine whether the given answer is correctly answering the question based on the reference text. Inside of GPT-4, we notice that the Q&A correctness rate is 1. In this use case, we can focus on GPT 3.5, since there were incorrect labels in this project. Once again, we'll look at the question previously, does Arize support training data? Again, Arize doesn't support the training data was the answer. Q&A correctness eval labeled this as incorrect with the answer that the reference text clearly stating Arize supports various model types. However, the reference text does not mention that Arize doesn't support training data. Because of this, the answer doesn't align with information provided. The second question with an incorrect label is about batch models. The output says that Arize supports various model types, but the reason that this was labeled incorrect is because while model types are mentioned, the answer doesn't mention batch models, and because of this, the answer is incomplete and does not fully address the question. This helps to illustrate the value of Phoenix projects and where they can become useful with performing A/B testing. Thanks for watching.